Now I would like to invite Mr. Shyam Kulkarni from he's from Pune, expert in foundry and data analytics now, to give a presentation on how real-time data has helped foundries.
Good afternoon, everyone. Mr. Ajay Vaswani and Manish Kothari, thanks for giving me opportunity. Basically, I am a foundryman like you only. I did my metallurgy and started working in the foundry right from 17th. And then I was with furnace manufacturer also. And some new scheme or new provision has been done by nano machines, which I have seen at some places. So I would like to tell you the benefits of that system and how are the advantages to all the foundries. First thing is, in foundry, data keeping is very poor in some of the foundries still. Some of the foundries keep data very correctly. But if I go and ask them some data, what is your power consumption, or what is your KVA, or what is your power factor, some people give reply to me and some people are not aware what is going on. They are only interested in more production and dispatches and then quality. But these are the very important factors: how much energy we are saving, where we are spending money. So all data is to be collected correctly, and many of the people, they have installed energy meter at different places, but energy readings are taken by manually, and in 24 hours, suppose you have 10 energy meters and at 10 locations, people keep on moving at different places, and instead of 8 o'clock, the energy meter reading is taken at 8:20 or 8:30, so you don't get a correct data of 24 hours, but you calculate that data on your 24 hours production. So there are always error in getting the data and analyzing it correctly. Like energy consumption in melting. Normally in foundry, those who have induction furnaces, electricity is consumed in major e- major electricity is consumed in induction furnace. Almost 65 to 70% is consumed in induction furnace. So in what way we should have a record? Furnace running at full power always gives the better productivity, better melt rates. But is it running at full power? Suppose you have 500 kilowatt furnace into 24 hours. Are we consuming that much energy? At what time the power drawn was less than 500 kilowatt? If you draw less than rated kilowatt, your production is affected. Definitely, you will get a melt rate. So all these graphs can be made available, real-time data. Sitting it here also, you can see it in your foundry at what kilowatt furnace is running. And energy meter have almost 100 parameters like KVA, power factor, current in different phases. So whatever data is required for us, for example, unit converted into rupees also, that data also can be made available anytime. And 24 hours, after 24 hours, you get a report, summarized report. This is the yesterday's performance. Suppose you have 10 energy meter fitted at 10 different places like furnace, short blasting machine, sand plant, and whatever is there. So that data you can get a summary of all 24 hours. What is the maximum consumption, minimum consumption, what is power factor, KVA, and if these energy meters are connected to transformer also, there also you can see the losses of transformer. Normally no one is worried about transformer losses. Transformer manufacturer says about 2%, but it keeps on increasing. So transformer analysis can be done on losses, and you can decide the preventive maintenance schedule of transformer. So all these small factors and saves your money and it can predict maintenance. For example, sand mixer machine, I have seen at some places the current drawn required is 15 ampere, but in some cases it draws 25-30 ampere. So there are chances that motor will get burned. So you can get an alert from that energy meter that instead of 15 ampere, now it is drawing 20 ampere. So you can get SMS on your mobile that current drawn is more. Look at whether shaft is bent or bearing has gone, or sand instead of 300 kg he has put 400 kg. That you can always analyze it correctly. So these are the benefits of this system. In foundry, these are the area: environment, productivity, energy, maintenance. So all this can be monitored by putting a separate energy meter at different places. as I said, all energy spent on different things, it can be converted into rupees also. How much units you have spent and how much rupees you have spent, that can be analyzed. This graph shows the transformer, what is the power drawn, furnaces, how much units you have consumed, sand plant, office lighting. See here you can see the graph, in between there is blank line. So blank line shows that there is a time between two starting of the heats. If you spend more time, the power drawn will be zero for maybe half minute, 1 minute. Some foundries take about 5 to 10 minutes for charging and restarting the furnace. So that can be analyzed and that time can be reduced. It should be done in less than 1 minute. After furnace is tilted back, the furnace can be started within a minute. So that data we can see it on the graph and then take a corrective action. For example, one foundry I have seen that cold start furnace first heat used to take 2 times or 2.5 times the regular heat. Suppose regular heat is 1 hour, they used to take 2.5 hours. When I have seen the graph, then I have told them the procedure how to make first heat faster. It should not take more than 20% time for the first heat. So if you have data, you can analyze it and then take a corrective action. But if you don't have data, you cannot analyze it and you cannot take a corrective action. For example, then I was telling about KVA. Whatever KVA you have contract demand and billing KVA 750 KVA, but looking at the graph, rarely it goes to 750 and balance time it works at 500 KVA. So by improving power factor also you can reduce KVA. So power factor data you can get live data on different machines, induction furnace, sand plant, whatever machines you have, you can get a live power factor data and then correct the power factor on that equipment. You can add capacitor to improve the capacitor, and by getting unity power factor your KVA demand will come down and you can save. And if you want to log KVA, normally people install PLC based maximum demand controller or alarm based. In this case, you don't have to install any equipment. Your KVA alert will use. You don't want to cross 500 KVA, it goes to 501. You will get SMS. Automatically, 4 people will get SMS, and they can reduce the power on any equipment or furnace can be reduced. So you don't overshoot your maximum demand also. By improvement of power factor from 85 to 95, you can save almost 200 kVA in your billing factor. Used to take 2 times or 2.5 times the regular heat. Suppose regular heat is 1 hour, they used to take 2.5 hours. When I have seen the graph, then I have told them the procedure how to make first heat faster. It should not take more than 20% time for the first heat. So if you have data, you can analyze it and then take a corrective action. But if you don't have data, you cannot analyze it and you cannot take a corrective action. For example, then I was telling about KVA. Whatever KVA you have contract demand and billing KVA 750 KVA, but looking at the graph, rarely it goes to 750 and balance time it works at 500 KVA. So by improving power factor also you can reduce KVA. So power factor data you can get live data on different machines, induction furnace, sand plant, whatever machines you have, you can get a live power factor data and then correct the power factor on that equipment. You can add capacitor to improve the capacitor, and by getting unity power factor your KVA demand will come down and you can save. And if you want to log KVA, normally people install PLC based maximum demand controller or alarm based. In this case, you don't have to install any equipment. Your KVA alert will use. You don't want to cross 500 KVA, it goes to 501. You will get SMS. Automatically, 4 people will get SMS, and they can reduce the power on any equipment or furnace can be reduced. So you don't overshoot your maximum demand also. By improvement of power factor from 85 to 95, you can save almost 200 kVA in your billing factor. This is graph showing power factor whether some of the furnace equipment or some equipment use lower power factor if they are not operated at rated power. That is a drawback of some equipment. So you have to have capacitor for corrective power factor, and you should get uniform power factor or unity power factor for getting minimum kVA demand. This utilization. Here you can see that this line, at some places the graph has gone above the line. So if you can get an alert that my maximum demand is shooting up, you can always reduce it and save on penalty of maximum demand. This motor alerts, as I said, if shaft is bent or loading is bore or bearing is not correct, you can get, I have been associated with some foundries, I get alert. Just now I got alert that sand mixer current has gone up. So people are working, maintenance people are working on that sand mixer wire current has gone up. Here you can see the power drawn on furnace. How is the graph? So this graph is to be improved. Normally furnaces should draw full power right from beginning to the end of the melting. There are habits or some equipment doesn't draw the power or charging is not good. So you are drawing lower power. So there should be practice to draw full power on the induction furnace right from beginning to end to get a better melt rate. After, as I told you, that after every heat is over, people take a long time for charging, and that can be, and you know, we don't stand on furnace platform for 24 hours. What we should get data on graph next day, how much time was spent in between two hits. So that data can be analyzed. I have seen in 24 hours, the utilization of power, 100% power was only for 12 hours. And balance 12 hours, either it was zero or lower power. Even if it is zero power for 5 minutes, you can get an alert from the system that your furnace is at zero power or it is off for more than 5 minutes. So you can find out why the furnace is off. Whether they have gone for lunch or there is no load or there is breakdown, you can get an indication. You can get an alert if furnace is working at zero. And this all alert can be set manually, whatever we want. This system is very comfortable, very useful, and many of the foundries are installed because this system we are installed in high tension user in many places like refrigeration industry or chemical industry. Hello. So this system has been used at so many places, proven system only when it is introduced to foundry. As a foundryman, I am involved in that. And if you want to know something more about this system, you can ask me afterwards. Thank you.
Thank you, Mr. Kulkarni, for sharing. One of the graph which was there earlier is called sand reclamation machine, which is working at Aquasoft. The machine data for the PLC is acquired and is available on the cloud, where the customer can see whether the machine is working or not. And if they are saying they are producing 445 tons per month, we can measure and say that it is done or not. So that information can also be available using data analytics.